Whenever we talk about humidity, the simplest definition that comes into your mind is what it basically refers to the water vapor that is present in the air. But something that we make mistake is humidity capacity means that to what extent water vapor can be held, but what is present actually is basically referring to the absolute humidity. We had earlier studied about humidity, we studied about evaporation, we studied about condensation. Now condensation, after condensation, if moisture is falling on the Earth's surface, it is precipitation. Variability means between that how much variation is there annually when the rainfall bed is received throughout the year. Hello aspirants, welcome to PW Only IAS. I'm here Harpreet Singh with another very interesting chapter from the Physical Geography series. The chapter is chapter number 10, Water in the Atmosphere. Now please remember, this has a lot of concepts which are very important for your preliminary examinations as well as a mains examination. Very often UPSC tests you on the concept of humidity, evaporation, precipitation, and all these concepts are something that you need to understand and to rote learn. Not only for your prelims but also for your mains. So we're going to understand each and every concept here, analyze the intricacies associated with it, and along with it, make sure that we learn it, revise it again and again, so that any question that comes in your prelims or the mains examination, you're able to do it very well. So let's begin with today's lecture. This is a QR code where you can find this particular PDF along with the other aspects related to anthropology optional, society, social justice, and civil services in general. So, water in the atmosphere. Now, please understand, when we are dealing with this particular topic, what topics are we going to study? See, firstly, we'll study what is humidity, the types of humidity, something that very often students find it difficult to comprehend because you generally study one definition of humidity, but there are a lot of types also. So you need to analyze and understand each and every one because these questions have been asked repeatedly in your prelims. Then, what is the concept of evaporation? What are the factors that are impacting evaporation? These topics, though, you have studied in your school days also. But again, UPSC tests you on the understanding part. Next is condensation, clouds, and then precipitation. So we're going to study all these topics, and let's begin with today's lecture. Okay, humidity. Whenever we talk about humidity, the simplest definition that comes into your mind is what it basically refers to the water vapor that is present in the air, right? But something that we make mistake is, please understand, whenever we talk about water vapor over here refers to air, a component of the air. It has got nothing to do with dryness or wetness. This is something very, very critical. I'll explain you here also. It has got nothing to do with the dryness or wetness indirectly when we talk about the atmosphere. It is itself an air. Now see here. In general terms, it refers to the water vapor content in the air at any one time and place. So this is the generic definition of humidity. We'll go into the types also. So what does water vapor refer to? Water vapor basically refers to the water vapor, humidity refers to the water vapor that is present in the air at any one time and place. Now, when I talk about water vapor, I am not directly talking about other things. See, this term is not used to describe liquid droplets. Please remember that. We are not talking about condensation here right now. Please understand that. We're not talking about condensation. It is like an air. Water vapor is also a component of an air. Right? Over here, that is why please understand, we are not talking about any fog, cloud or rain. Condensation, how it takes place is a different scenario altogether. Whenever we talk about water vapor, it is simply refers to the water vapor in the air, and it is not used to describe the liquid droplets. Later on when condensation takes place, how those phenomena take place, that is a different scenario altogether, right? Water vapor is dry like any other gas, right? It is a component of an air, and like any other gas, like you have nitrogen, you have oxygen, water vapor is also what? A gas. Like any other gas, it is dry. It has nothing to do with dryness or wetness of atmosphere. See, it has got nothing to do with dryness or wetness of the atmosphere. Like any other gas that is present in your atmosphere, nitrogen, oxygen, argon, similarly, water vapor is also like a gas that is present in your atmosphere. By default, it has got nothing to do with that wetness or dryness. Yes, when we go ahead with the concept of condensation, then we will talk about these things, but humidity, no, right now it has not got nothing to do with that. There is spatial and temporal variations, but amount of atmospheric water remains nearly constant. See, there will be certain variations. For example, in the regions which are close to the, let us say, oceans or oceanic regions, will have a higher supply of water available there. So obviously the humidity might be more in comparison to the interiors of the continent, right? Similarly, humidity, or let us say the available water supply is more in the equatorial region than in the polar region. So it will be more in the equatorial region. Yes. So that is why when we see the variation of water vapor, let us say in the air, varies from 1 to 4%. This is a variation which even your NCERT very categorically mentions. So you should be very, very clear about it. It varies from 1 to 4%, right? So, but moreover, it is this constant percentage that is there, right? So you can note it down also, you can stop the video. Now the question comes, having understood humidity, because again, many people will again have a problematic issue. Why? What they face is that, sir, when humidity is there, then it is little wetty feeling. Please understand, it depends upon a lot of atmospheric conditions along with it. In the phase of, let us say, it is about to rain or condensation has taken place, and all those phenomena also impact a lot. So right now, when we talk about water humidity, we're talking just about the water vapor that is present in the atmosphere, and it is like any other gas that is present. So do not confuse it with the phenomena of condensation, because when we talk about rain, clouds and all, it is basically the condensation that has taken place, and then those phenomena take place. So right now when we talk about humidity, that is water vapor in the atmosphere, we are not concerned with another phenomena that are taking place right at the moment. So that is why it is considered like any other gas, which is itself dry in nature, and it has got nothing to do with the dryness or wetness in the surrounding atmosphere. Clear? Now, when the question comes, okay, now let us, now please tell us, sir, there are a lot of types of humidities also we study. I'm going to tell you about certain humidities which possibly you might have not studied or have a little problem in understanding. So we will make it clear also. Please remember this, that there are a lot of phenomena, a lot of concepts that have to be understood if you want to understand the concept of humidity. Under the humidity category, you need to understand what is humidity capacity. You need to understand what is absolute humidity. You need to understand what is relative humidity. Once you have understood these concepts, it is very easy that what humidity basically means. When I talk about, let's go with the first concept. Humidity capacity. When I talk about capacity, what do you mean by capacity? Supposingly, I have a bowl, right? Now, the maximum water that I can put in the bowl is 1 liter. So what is that? That is the capacity. Now, similarly, when I talk about humidity capacity, it is the amount of water vapor that at a given point of air can hold at a given temperature. So if there is, let us say, some amount of air at a particular temperature, what is the amount of water vapor that this air can hold? That is why, see, the amount of water vapor that a given parcel of air, let us assume this is a parcel of air. Now, let us say at temperature T degree Celsius, right? It can hold certain amount, let us assume 10 grams, let us assume. Clear? And there is certain volume present here. So based on that, what I am trying to do is, I'm trying to measure or calculate in a way, what is the amount, that means it is, we're talking about the weight only. You can say that is why it is measured in grams per centimeter cube. That in certain amount of weight that can be present in certain volume of air. So it is the amount of water vapor that a given parcel of air can hold at any given temperature. Why temperature? You know that very well, when the temperature changes, the humidity capacity will change. Why? Because there is expansion of air. If at a certain temperature, this is a parcel of air that is present. When I increase the temperature, what will happen? The expansion will take place. Intermolecular spaces will increase. If it will increase, the capacity of the air to hold water vapor will be more. So with increasing temperature, we will see that the capacity of the air to hold more water vapor will be present. So that is why the concept of humidity capacity, that means it increases with the increasing temperature. So again repeating, the amount of water vapor that a given parcel of air. So it is the amount of water vapor that any given parcel of air can hold. Importantly, at a given temperature. This is known as humidity capacity. It is measured at grams per centimeter cube. That means the amount, and in the what specific volume of air it is present. Next is moisture holding capacity of air increases with increasing temperature. Now, how? As I've told you, if at certain temperature, this is let us say a graph representing the temperature increase, this is the humidity capacity. At let us say certain temperature, let's assume it hypothetically that at this particular point, let us say the temperature is let us say 10 degrees Celsius. And over here, let us say it can hold, let us say 10 grams. Now, similarly, the temperature increases possibly at 30 degrees Celsius. It might go to, let us say 20 grams, let us assume hypothetically. So, what does it basically mean? It means that with the increasing temperature, the humidity capacity will increase. Is it clear? The concept should be very clear. Now comes a very interesting topic. After having studied the concept of humidity capacity, let us move on to the concept of absolute humidity. Now, humidity capacity is a basic concept which helps us to understand the humidity definitions as well as the other concepts. What is absolute humidity? It is the weight of water vapor per volume of air. What it is? Earlier one was just telling about the capacity, right? It is telling about the capacity it can hold. It is not telling about the humidity. Please remember that. When I talk about humidity capacity, it is a capacity, that is the amount of water vapor that can be held in a parcel of air. It is not a form of humidity. It is not a form of humidity. But a concept to understand humidity. That should be very clear. It is not a type of a humidity, it is a capacity. What it can hold, what it is holding or not holding, that is a different scenario. Okay? Chaliye. Now, remember, capacity means the maximum level it can hold. When I talk about absolute humidity, it is referring to the weight of water vapor per volume which is actually present. Capacity means that what it can hold, and absolute humidity is what it is holding. Now, why it is important is, like for example, your parents believe that you are going to get, let us say in a mathematics paper in class 10, 100 marks out of 100. That is the capacity that we believe that you will be getting. That is the maximum. But you actually get 95. So what you are holding, right? Similarly, absolute humidity is the weight of the water vapor per volume of air. That was a capacity. So obviously over here also it is grams per meter cube. It decreases from equator towards the poles. Why? At the equator you will realize more amount of water vapor is available because it is again a lot of rainfall is also happening. Over the oceans, from ocean towards the continent it decreases. Why it is more over the oceans? Because over the oceans you realize there is more supply of water vapor that is available. At the continents there might not be the case, right? Similarly, you can see as the temperature is increasing, the absolute humidity is also increasing. Now please remember one thing. It is quite possible, this is fact, with the absolute humidity which is increasing with temperature, it might not be meeting the exact capacity. When it reaches the capacity, it becomes saturated. Do you realize this? Now, humidity capacity means that to what extent water vapor can be held, but what is present actually is basically referring to the absolute humidity. Clear? Next, we have done with the absolute humidity. Let's begin with specific humidity. See, one needs to analyze this. This concept is a little different from the previous concept that we have studied. Now see here, specific humidity, sometimes people find it very difficult because over here a very important line is written that it is not affected by changes in temperature and pressure. Now you'll be thinking it is humidity and how it is not being impacted. So let us understand that. It is not because it is humidity in per se, it is basically the concept that we are dealing with. Now see here, it is basically what? It is a ratio, right? It is a ratio. Now in this ratio, it is what it is? Mass of water vapor upon the total mass of air. The total mass of air includes the mass of water vapor plus the other gases, that is the dry air. So this is the ratio which we are talking about. Similarly, let us read it. It is the weight of water vapor. It is the weight of water vapor per the weight of a given mass of air, including the water vapor. Clear? Clear? It is measured in grams of water vapor per kg of air. Grams of water vapor per kg of air. Now, it is not affected by changes in temperature and pressure. Let us take an example. If I increase the temperature, what will happen? The humidity capacity changes. That is why the previous phenomena where we were talking about aspects of humidity capacity and all, are we dealing with humidity capacity here? No. Are we dealing with volume over here directly? No. What are we dealing with? We are dealing with the mass, weight. So, with the change in temperature, there is change in humidity capacity. But is the humidity capacity being changed here because we are taking the mass only? So, by changing this temperature, there is no change in these ratio. It will not be changed. That is why it is not being impacted by change in temperature also, and for that matter, pressure also. So that is why, please remember, specific humidity is not impacted by changes in temperature and pressure. But you will see that there is relatively higher specific humidity near the equatorial region. That is because more amount of mass of water vapor is present there. Just because of the supply, the more mass is present, that is why we see a little bit increase over here. That is it, nothing else. And it keeps on decreasing as we move towards the poles. Now, please understand, because we are not changing the humidity capacity, that is why it is not affected by changes in temperature and pressure. Clear? Let's move ahead. Relative humidity. Now, relative humidity again is a concept that is expressed in a percentage. What it basically means? It means absolute humidity upon humidity capacity. See, the previous initial two concepts that we had done, we had talked about humidity capacity and we had talked about absolute humidity. It is basically the ratio of these two. What does it mean? See, I told you that there is, let us assume, a humidity capacity where a certain parcel of air can hold, let us say, 100 grams maximum of water vapor. But in reality, you see that only 50 grams of water vapor is present. So that means there's a difference between the capacity and difference between actually what is the water vapor present. This is what is being referred to here, over here. That absolute humidity upon humidity capacity into 100. So that means it is referred to as or expressed in the form of percentage. Let us see. It is defined as a ratio of the amount of water vapor in the air to the amount of air it can hold at that temperature. Yani at what specific temperature? At any specific temperature. So because you will see, because over here humidity capacity is present, so by default there will be certain change present there if there is change in temperature. Let us see this. Relative humidity changes if there is more addition, if it will increase if there is more addition of moisture. How will it increase? Please understand. Humidity capacity is there. Humidity capacity is fixed for any specific temperature. Now let us assume at any specific temperature, there is, let us assume, humidity capacity of this circle. Let us assume this circle is capacity and this is what? Humidity. If let us say there is capacity of, let us say a humidity capacity is, let us say 100 grams, let us say for a parcel of air, for a certain parcel of air. What do you mean? That means per volume. Now, this is, let us say, 100 grams. Initially, what we saw, humidity capacity was, absolute humidity was, let us say, at any specific temperature, let us say 50 grams for a parcel of air, because it is in a ratio of weight upon volume, right? Parcel of air. What do you see? 100 upon 50 into 100, that means 50%. Now, I'm not changing the temperature. That means there is no change in humidity capacity. Now, let us assume I'm not changing the temperature, still the humidity capacity will be 100 grams. Now, let us say I add more moisture. From 50, it has become to 70 grams for a parcel of air, So that means now the ratio will be 70 upon 100 into 100. What does it mean? 70%. That means with more addition of moisture at that specific temperature, I am not changing the temperature, please. With change in temperature, there will be a lot of changes. So with more addition of moisture at any specific temperature or without change in temperature, the humidity, this relative humidity will increase because the denominator remains same, the numerator increases. So if the numerator increases and the denominator remains the same, it will be increase in the relative humidity. Now concept comes is, sir, you have written here, it increases with decrease in temperature. How? Just remember this. Let us assume, let us understand this decrease in temperature. Supposingly, at initially, there was some temperature. Let us say initial condition is temperature is, let us say, 20 degrees Celsius. And I say at that particular temperature, the humidity capacity is, let us say, 100 grams for a parcel of air. Parcel of air. I could have written it grams per meter cube also. It is same, right? Parcel of air. That means for a volume of air. But the absolute humidity over here is, let us say, 50 grams per centimeter cube. Over here, this can be written as 100 grams and so on. Let us say I'm taking the same unit, centimeter cube for here for the timing. Just understand. Just imagine it. Now, this is a temperature, this is a humidity capacity, this is the absolute humidity. Capacity is 100 grams, humidity is, let us say, 50 grams, temperature is 20. Now, if I decrease the temperature, let us assume now over here, what is the relative humidity? It is basically 50 upon, let us say, 100 into 100. It is basically coming out to be 50%. Okay. Now let us decrease the temperature. Temperature becomes 10 degrees Celsius. Temperature becomes 10 degrees Celsius. Now you know one thing, that with the decrease in temperature, the humidity capacity decreases. Let us assume initially the humidity capacity was 100. Now it becomes, let us say, 50 grams for a parcel of air. What has happened is, with the decrease in temperature, the humidity capacity has decreased. But the absolute humidity, let us assume the amount of water vapor, this amount of water vapor that was present is the same. So let us say the absolute humidity that was present is 50 grams only, because the moisture that was actually present is 50 grams only. Now you realize that the denominator has decreased, but the numerator is same, into 100. So it is 100% now. So the relative humidity is 100% now. So that means earlier it was 50%, is 100%. Now, so what happened? Relative humidity has increased with decrease in temperature. Why it is happening is, simple concept is, with the decrease in temperature, the humidity capacity decreases. The absolute humidity is similar, because why? Because it is basically having a parcel of, that is the water vapor that is present. So that is in grams, that is same. Capacity will decrease, that means the numerator is same, the denominator is decreasing. In the specific aspect also, if you studied basic mathematics, if the denominator is decreasing and the numerator is same, the ratio will increase, or the percentage will increase. That is why there is increase in relative humidity with decrease in temperature. Clear? Let us understand this. Okay, let's move ahead. When we come here, let us say similarly, this what I have explained you over here, this is basically a representation of the similar content which I have explained you here also. Clear? So let's move ahead with these similar concepts over here. Having done humidity, let us go to evaporation. Now please understand, when we talk about evaporation, there is a big misconception that for evaporation you need to have a very high temperature and all. See, yes, temperature helps, but it does not mean that merely at a boiling point it is going to happen. No. Boiling is a very different phenomena. Remember that whenever a liquid surface is present, let us assume, there is certain kinetic energy that is present. Even little bit temperature that is present has some kinetic energy that is being supplied to the water molecules. The ones which are on the top layer, surface layer, whenever they get certain amount of energy which helps them to escape, because if, let us say, intermolecular spaces is weak, if they get certain energy and they free themselves, these water molecules basically escape, and that is why that is a phenomena where there is change from the liquid state to the gaseous state without actually reaching the boiling point. So evaporation is taking place continuously at all the temperatures. Boiling is obviously at a higher temperature, it depends upon the nature of liquid. So you will realize that at the surface layer, at the surface layer, when a kinetic energy at certain temperature is being supplied, the water molecules or whatever molecules, if they are able to free themselves from the intermolecular spaces, they will escape, and they will escape in the form of the gaseous state. That is why these are high kinetic energy molecular escape. In the liquid state, this is the gaseous state, which is because of evaporation it has happened. Now, the evaporation is a process in which the molecules on the surface of the liquid escape into the gaseous state before actually reaching the boiling point. So please do not assume that only at a boiling point the water changes into, or liquid changes into the gaseous state. No. It basically, this is a continuous phenomenon that takes place. Even if certain amount of, let us say, energy is supplied, let us say you are sitting in a room and there is some liquid kept, not necessarily water. If let us say you put on an air conditioning, let us say where heating is being done, possibly little 2-3 degree temperature increase also might give sufficient energy for a liquid to surface layer, because surface layer is the one having the higher kinetic energy, lower layers lesser. So that amount of energy which helps them to escape and leave the liquid state. So that means that evaporation is taking place continuously at all temperatures. Okay. What are the factors impacting evaporation? Now, these are certain factors which are very important. Let us understand, because this is a question which is asked in UPSC very often. See here, temperature. You know that very well when I talk about temperature. With increase in temperature, the capacity of water evaporation increases, right? Because why? Because where the temperature increases, the amount of energy that the molecules will get, but at the surface level of a liquid will increase. So there is greater tendency for them to leave the liquid and change into the gaseous state. So in higher temperature, higher the temperature, more the evaporation. Greater the evaporation. Greater the evaporation. Clear? Humidity. Now you please understand, humidity basically refers to the water vapor that is present in the air, right? If there is already very high humidity present, then there is lesser capacity for the air to hold more water vapor molecules, let us say water vapor. So if there is already a lot of humidity present, there will be lesser tendency for more evaporation to take place, because the air cannot hold that amount of water vapor. So greater the humidity, lesser is the tendency of evaporation. Why? Because the evaporation basically changes a liquid state to the gaseous state. Now water is being added. Let us take the example of water. If water is being added to the air or the atmosphere, let us take air only. In that particular case, if already a lot of water is present there, it cannot hold more water because it might go beyond humidity capacity. So that is why already if more the humidity is present, lesser can be the evaporation rate. Wind speed. You know that very well, that as I've told you, when certain region has, let us say, certain humidity or whatever be the conditions, if the winds are flowing, they might remove whatever moisture is present in the air, and then the evaporation, more evaporation can be there because there is, let us say, lack of water vapor in that particular parcel of air. So greater the wind speed, there is greater tendency of more evaporation to take place. Chances of more evaporation. Please understand, when I am talking about one factor, I am taking that factor only. I am keeping other factors constant, because if I take all the factors together, the result is very different. When I'm talking about one factor, I'm taking just one factor. Greater the wind speed, chances of more evaporation. Surface area. Now please understand, this is the surface area which is exposed to evaporation, and this is the surface area which is exposed. So greater the surface area, greater is the chance for evaporation to take place. More is the evaporation, because more is the area, because it is a surface level phenomena. So greater the surface area, more is the area through which basically evaporation can take place. So greater the surface area, greater the surface area, greater the surface area, greater is the possibility of evaporation. Nature of liquid. Now please understand, every liquid is different with respect to boiling point and its characteristics. Please understand, when I talk about nature of liquid, there are certain liquids which are more volatile. Let us say they have lesser intermolecular forces that are binding the water molecules. Let us say if you keep a glass of water and you keep a glass of alcohol, you will realize that evaporation with respect to alcohol will take place at a very rapid pace. Or let us say the spirit that is used in the paint job. When you do painting in your houses, painters would have come, they would have used spirit to dilute the paint. You will realize if you leave the spirit outside, it will evaporate because lesser intermolecular spaces are existing between the molecules in that liquid, but particular liquid. So, nature of liquid, more volatile liquid more or greater is the rate of evaporation. Greater is the rate of evaporation. Atmospheric pressure. This is something very important. You know that very well that atmospheric pressure refers to that pressure that is being exerted by a parcel of air on any object, or us also for that matter. If the atmospheric pressure is less, let us go to hilly regions. That means there is, let us say, a liquid pressure being acting, and then there is the atmospheric pressure. Now, if the atmospheric pressure that is exerting as a weight, column of air, a weight is being exerted, it is less. Greater is the chances for evaporation to take place. So, lesser the atmospheric pressure, greater is the possibility of evaporation to take place. Lesser the atmospheric pressure, greater the chances of evaporation. So you have seen certain factors: temperature, humidity, wind speed, surface area, nature of liquid, and atmospheric pressure. These are important factors which you should know because these are repeatedly asked in your civil services preliminary examination. This can be asked in your mains examination also. Let's move to certain questions which are here. Please understand, these questions are for your practice. The answers will be put in the comment section by me. So I'm not going to discuss the questions here. I'm just going to show you and we will be discussing. I would request you to write the answers in the comment section. First, consider the following statement regarding evaporation. Evaporation is a surface phenomena. Evaporation can occur at all temperatures. Evaporation always increases with increase in atmospheric pressure. Which statements are correct? 1, 1 or 2, 2 or 3, 1, 2, 3. You can pause the video here. Answer. This is question number 1, right? Next. Consider the following statements. Evaporation increases with increase in wind speed. Evaporation decreases when relative humidity is high. Evaporation is independent of the nature of liquid. A, 1 and 2, 2 and 3, 1 and 3, 1 and 2, 3. Pause the video here. You can answer in the comment section. Third, consider the following statements of evaporation at high altitudes. Evaporation is faster at high altitude due to the low atmospheric pressure. Water boils at a higher temperature at high altitudes. Lower pressure reduces the energy needed for the molecules to escape. 1 and 2, 2 only, 1 and 3, 1, 2, 3. You can pause the video, answer this question in the comment section, right? So these are the 3 questions which I expect you the answers in the comment section. So please do it. It is for your practice. These are the types of questions that are asked in the civil services paper also. Condensation. Now please understand, it is a simple phenomena where we see that condensation is a phenomena where the water vapor basically changes to the liquid state. Now, you remember that time when I was talking about water vapor being present in the atmosphere. Now, when I'm talking about water vapor, there is a difference. For example, humidity capacity and what it is holding, absolute humidity. I told you that simply talking about water vapor in the air does not mean we are talking about water droplets. It is like a gas that is present. Now, that gas to change into certain other form, there have to be certain conditions, like it must be saturated. What do you mean by saturated? That means the amount of air, the amount of water vapor that is present is equivalent to the capacity that it can hold. Saturation is that means the absolute humidity or the humidity capacity They're equal, right? So that means 100%. So that means the relative humidity is what? 100%. Necessary surface or object on which it can condense. Now please understand, for the condensation to take place, you need a certain condensation nuclei or surface. For example, rain droplets also, if there is certain condensation nuclei, let us say a small ice droplet, let us say a dust particle, then it can condense on them. That is why condensation surface or condensation nuclei is important. This is again very critical conditions which should be there in order for the condensation properly to take place. Let us take the types of condensation. Now please see. Dew. Very often nowadays you are seeing the dew being present. Before we study this, let us see the photograph. Do you see these leaflet that is there? These are water droplets that are present on top of it. Yes, these are water, not ice particles. These are water droplets. This is basically referring to as dew. Now what it is? When moisture is deposited in the form of water droplets on the cooler surfaces of the solid objects like stone, glass plates, it is referred to as dew. So in solid, in the early mornings you will see that water droplets being deposited on surfaces. Let us say in the morning, today's time when it is already cold, in the morning you get up, you see water droplets on the car, windshield and all also. So this is also the similar phenomena. For dew, it is necessary that the dew point is above the freezing point. So because it is in the liquid state, it should not be beyond the freezing point. It is if beyond freezing point, then what will happen? It will be possibly in the form of ice particles, right? So it should be less than the freezing point. Ideal conditions: clean sky, calm air, high relative humidity, and cold and long nights. So these are the ideal conditions which are present in your NCERTs also, and these are the questions that have been asked in your civil services. So these are something that you should keep in mind also. Now comes frost. Now please understand the difference. Dew over here is the water droplets being deposited. Frost is, let us see, these only are in the form of, let us say, ice, right? So forms on cold surfaces when the condensation takes place below the freezing point. So you see ice particles over here rather than water droplets, because the condensation is taking place below the freezing point. That is why it is all icy crystals and particles that are present here. So this is the difference between frost and dew. It is taking place above the freezing point. It is taking place below the freezing point. Clear? Next comes fog. Now again, something which has been there in the news repeatedly. Yes, Delhi has smog. That means an outcome of again pollution also, but majorly this is the condition which you see, very dense fog. Now see, when the temperature of a parcel of air containing large quantity of water vapor suddenly decreases, condensation takes place itself on fine dust particles. Now let us assume there is moisture in the air, yes, and you realize that the temperature suddenly decreases. When the temperature suddenly decreases, you realize the humidity capacity decreases. And then obviously it will help in what? The condensation to take place, because the air might become saturated at that time. Now that time, whatever dust particles are present there, it will saturate, it will basically condense on those particles. And that is why you see such types of condition. That is why in the winter months, you see such dense fog where the humidity, capacity, that is the humidity capacity decreases suddenly. And that is why such conditions are there. During the daytime, why does this fog vanishes? Because of the sunlight, the capacity of air to hold water vapor basically increases. Water vapor is present in the air, but it increases because there is expansion of air. That means the humidity capacity is increasing because of the increase in temperature. But during the night time or evening time, when the temperature cools, the humidity capacity decreases. So what happens? The air might become saturated. And that is why you will realize the condensation takes place on the dust particles over here. Mist, it is also same as fog. The only condition is that there is more moisture present here. So this is fog and mist, again go parallelly. Now see clouds. Now clouds, please remember, is also a form of condensation. Also a form of condensation. Now I have taken a very standard classification which internationally United Nations also uses, and NCERTs also mention it. They give a simplified form, but these are sometimes have been asked in various examinations, so you should be having an idea of it. I have labeled so many clouds here, right? I have drawn the diagram of the clouds also, and I've explained what these clouds are, the knowledge that you should have. So quickly we'll do it. This is something that you need to just revise it twice and thrice and 4 times. You will be in a condition to understand it. Now clouds are again aggregate of innumerable water droplets. Yes, you know that very well. This is an outcome of the condensation that has taken place of the water droplets. It might have ice particles and mixture of both in the air, generally above the ground surface. So it is taking place above the ground surface. Now formed due to the condensation of water vapor around hygroscopic nuclei. Hygroscopic nuclei against condensation nuclei, because for even the clouds also, they need a medium through or place through which they can condense. So that is why when you do the cloud seeding, you are basically providing a means for the condensation nuclei to be there. Clear? So condensation nuclei being present, only then they can basically condense. Now based on that, you realize that there are a lot of clouds at a classification that is present. There are certain high clouds present at a very high height, a greater height, 6 to 20 kilometers, like cirrus clouds, cirrocumulus clouds, and cirrostratus clouds. Let us do it along with it. Cirrus clouds, cirrocumulus cloud, cirrostratus cloud. You see here, cirrus cloud, cirrocumulus cloud, and cirrostratus cloud from 6 to 20 kilometers. So see here, cirrus clouds are high altitude, fibrous, like a fiber, cotinate type also. Fibrous, silky appearance, indication of dry and fair weather. When I talk about cirrus cumulus, these are white colored. These appear as ripples. Can you see? These are like small ripples that are present. Rare and associated with bad weather conditions. Cirrostratus over here, again cirrostratus. Like a milky, like thin sheet is present here. Form halos. You can see halos here. Form halos. Represents rising warm air along the front, and intense rain is associated with it, right? So it is basically a very, very important three categories under the high clouds. Let's come to the middle cloud. The middle cloud is basically from 2.5 to 6 kilometers. It represents altostratus, altocumulus, and nimbostratus. Now see here, you will see nimbostratus here, altostratus over here. So let us see a little bit about them. Middle clouds, altostratus, thin sheet of gray or blue having fibrous or uniform appearance. Altostratus, see this. Thin sheet of gray color, it is grayish in color, or a bubble having fibrous or uniform appearance. They do not form halos. Unlike the previous cirrostratus where you see halos, they do not form halos. Widespread precipitation and bad weather conditions are associated with altostratus. Now, altocumulus, wave-like layer of globular form, white or gray in color, associated with bad weather conditions. Nimbostratus. Now, please understand, sometimes people get too confused over here. So, please understand, this is what nimbostratus. Right? Nimbostratus. Dark colored clouds associated with rain and snow, but not hail. Low clouds. Stratus clouds, cumulus clouds, stratocumulus clouds, cumulonimbus. Now, cumulonimbus is associated with convectional activity. Now, it is basically rises to a very high height because of the convectional currents. And that is why we have, it is present in all these dimensions. It rises from here and goes on up, right? So, though it is present in all the layers, it starts from the lower layer. That is why we have mentioned in lower clouds. Its length, its height, in fact, depends upon the case how strong the convective currents are. Stratocumulus, gray or whitish color, generally arranged in the line and are wavy, and occasional rain is there. Stratus, dense. Where is stratus? See, stratus here. Stratus, dense, dark gray color, but seldom close to the ground. It is associated with good weather and sometimes rain. Cumulus, it is like a dome shaped. Let us see here. It is like a dome shaped. Dome-shaped, flat base, sometimes thunder. Last is the cumulonimbus, which is largest cloud which you see. This is again associated with a lot of convectional currents, right? Intense updraft of air that happens. That is why these might range, even go to, let us say, 12 kilometers height. Depends upon the nature how strong it is. It might restrain to lower heights also, depending upon the nature, right? Now, these are thunderstorm clouds. These are associated with vertical development, heavy rain, snow, hailstorm, and lightning. We have already done this in the previous concept where we saw a lot of tropical cyclones, cyclonic activity associated there, where we had mentioned about these cumulonimbus clouds being formed. So these are again associated very heavy rainfall. So these are very important or critical clouds. Please note it down quickly. Let's move on further. Precipitation. When I talk about precipitation, what is precipitation? It is a process by which the condensation, condensed atmospheric moisture falls to the Earth's surface. Now, you know that we had earlier studied about humidity, we studied about evaporation, all. We studied about condensation. Now condensation, after condensation, if moisture is falling on the Earth's surface, it is precipitation. Under the gravity in liquid or solid form, such as rain, snow, sleet, hail, or drizzle. Now, moisture that is falling on the surface of the Earth after the condensation has taken place is known as precipitation. Now, please understand, it is a final stage of hydrological cycle, right? Or water cycle as we talk about. Now, see here. Condensation, necessary conditions, high humidity, that is means water vapor is present. Saturation of air, that means obviously saturation will take place and condensation will take place, that is important. Condensation nuclei on which it condenses. And last, growth of droplets and ice crystals. Now, this is a phenomena. There are a lot of theories also which people study in the geography optional, right? How these crystals grow. That is not necessary for your general studies for that matter. Burgeon cycle and all that is there. But over here, we simply see that growth of droplets. That means one droplet is added to other droplets and the size of the droplet increases. Why it is important? Please understand. If a droplet size is very small, please understand, if let us say rain happens, but it will not reach the surface as the droplet size is very small. Yes, there might be a lot of, because when the water droplets are falling, they might even themselves get, let us say, evaporated. Why? Because they are falling from a large, very high distance. Let us say from a very high height, they are falling. That is why the size of the water droplet should also be larger, so it falls down. That is why most of the cases, even when it is raining, it might not reach the surface. That is why growth of the droplets and having an appropriate size of the droplets, whether it is in the form of liquid state or whether it is in the form of solid state. When you see hail also, we saw large ice particles that are falling, possibly in the air, let's just say 10 kilometers or 7 kilometers above, it might be such large sizes. But by the time it reaches the surface, a lot of melting activities, let us say reduction in the size happens. That is why even in spite of that, you see large sizes of boulders of ice that are present. Those are hail. We'll see that. Forms of precipitation. Now, please understand there are certain aspects you need to study. Raindrops where the diameter is greater than 0.5 millimeter. It falls in a liquid state and temperature of air column is generally greater than 0 degrees Celsius. That is why it is in a liquid state. Drizzle, it is very fine. Uniform droplets with a diameter of less than 0.5 millimeter. That means lighter rain. Falls slowly with slow intensity, common in stratus clouds. You know that rain, the lesser version of rain is drizzle, right? Then comes snow, precipitation in the form of ice crystals or flakes. The entire air column which is falling is less than 0 degrees Celsius. That is why snowfall is happening. Sleet, intermediate form between rain and snow. So it is basically a mixture of snow and rain that is falling. Hail, precipitation in the form of hard layered icy balls. It might range from few millimeters to even large centimeters also. Types of precipitation. Now please understand, this is again very, very important and critical. When I talk about precipitation, you have studied these concepts in your school days also. So what do we see here? First is the convectional rainfall, then you have the orographic rainfall, and then you have obviously the cyclonic. Cyclonic we have already studied in the previous chapter where we studied the tropical cyclone and the temperate cyclone. So we will not be repeating it over here. We've already done in detail. See here, convectional rainfall. What happens is due to, let us say, rapid, in this, see in simple form, you see there is updraft of air that takes place because of the convectional, and it leads to the formation of convectional currents. As moisture laden wind rises over here because of the convectional current, it over here is expanding, but as it reaches certain height, it will cool. After cooling, the temperature is decreasing, it will become saturated, and then condensation will take place. Now this leads to the formation of large cumulonimbus clouds. This CN that I have mentioned is basically cumulonimbus clouds. And what is taking place? Convectional currents. This is a type of rain that occurs when the sun's energy intensely heats the Earth's surface. Now, the Earth's surface is intensely heated. Ground heats the air directly above it and causing the air to expand and become lighter and rise. Now, if the surface is being heated, the air will become lighter and it will rise. Obviously, it has water vapor, and water vapor is also a gas at that time, right? As it reaches a higher altitude, it cools and forms cumulonimbus clouds. Now, please understand, when the ground is being heated, this is a heated surface, the air will rise. The air itself has all its constituents, including the water vapor, which is a gas right now. Now, because of the heating, the expansion takes place and it starts rising. After a certain time, you will rise, cooling will take place. Cooling will take place and saturation, and with time you will realize that cumulonimbus, huge clouds will be formed. Now it depends upon the temperature that is there, the conditions that are available there, it can be very huge also. And later on you realize there is condensation, and you realize very heavy rainfall is also associated with it. Usually occurs as heavy, short-lived downpours accompanied by thunder and lightning. This is what the convectional rainfall. Other is relief or orographic rainfall. Very often, like for example, in the Western Ghats region, you would have seen like moisture-laden winds are coming from the Arabian Sea. They encounter the Western Ghats. The moisture-laden winds basically try to rise. As they rise, what happens? They cool. When they cool, obviously condensation will take place over there, formation of clouds take place, and there is again precipitation. Right? So this is what is the concept. This side where rainfall is taking place, this is known as a windward side. Over here, most of the precipitation, whatever the moisture was present here is shedded over here. Over here, you realize lesser amount of rainfall is there because most of the moisture is shed on the windward side. This is known as a leeward side, which is on the opposite side from where the moisture-laden wind is encountered. So this occurs when an air mass is physically forced to rise a mountain or highland. So that means air that is full of moisture has come here and it encounters a mountain, let us say Western Ghats for that matter. It will be forced to rise. As it will force to rise, it will lead to cooling, and then slowly what will happen? It will lead to the formation of clouds and then condensation. Because of that, condensation process happens, and then what happens is clouds formation itself is a form of condensation, but you realize it will lead to a lot of rainfall in this particular region because of that. So the moist air blowing from the sea hits the mountain, forced to raise upwards, where cools and condenses into clouds. As the condensation takes place into clouds, obviously with time you will realize that rainfall will be there in this particular region. As yes, this region will have received certain rainfall, very minimal, but this is the main region. That is why it is known as a windward side. Let's move ahead. Cyclonic rainfall. Now this is associated with the presence of low pressure regions in the center. You know that very well. We have done in the previous chapter also. Anticyclones are high pressure regions that they are associated with what? Stability, right? Clear skies. Cyclonic conditions are associated with the center region being low pressure, and obviously it is of two types. You would have studied in the previous chapter the tropical cyclones and the temperate cyclones. Both are associated with a lot of rainfall activities. We have done this in the previous chapter, so please revise that because both the concepts are done. In the temperate cyclones, we have even done the various sectors also within a temperate cyclones where rainfall, various kinds of rainfall that is happening. Rainfall variation. Now see, this is a classification which we are going to do in the next chapter, but just written over here. If you see, this is how a classification is done. From 0 to 10, you have the equatorial rainforest. On the eastern side, you generally have monsoon, in the middle savanna, and the side tropical or subtropical desert. Let us say if you go from 30 to 45 degrees, on the western side, you have the Mediterranean type of climate. In the middle, steppes or temperate desert. On the eastern side, the temperate, the China type. If you go from 45 to 60 degree, you have on the eastern side, the Laurentian type. On the western side, the British type, and between them, Taiga type. From 60 to 80, you have the tundra, and beyond that, ice caps. We will be doing this in the next chapter, the classification, but just a reference. Why? Because I'll be using them in this classification, right? Now, rainfall variation, how it is varied. Let's see this. Greater than 200 degrees Celsius is present in the equatorial rainforest in the regions of Amazon forest, Congo Basin, Indonesia, and Malaysia. Monsoon region, that means over here, if you see, monsoon type of climate is present here. Like the western slopes of the Western Ghats, northeastern India, Vietnam, Philippines, Thailand, and coastal Myanmar. British type, areas of Washington State, Alaska, Colombia, over here, right? Next, 100 to 200, west of the monsoon areas, the areas on the west of the monsoon areas, like in parts of India and Southeast Asia. China type, in the regions of East Asia, receive these 100 to 200, East Asia and Southeast United States. Laurentian type, coastal areas of parts of China, Korea, and Japan. Parts of British type and large parts of the Savannah region receive close to 100 to 200 centimeters of rain annually. 50 to 100 in the interior parts of the monsoon climate like we see in India. Rest of the Savannah, coastal Mediterranean region, interiors of China type, Laurentian type, and British type, and parts of Taiga. 25 to 50 centimeters is basically referring to the semi-arid conditions, which we see in the boundaries of the desert like the steppes, we see in the shrub Mediterranean, continental parts of the British, Laurentian and the taiga type. When we go to the arid region, which is less than 25 degrees Celsius, we come across subtropical, subtropical desert and a temperate desert. Tropical, subtropical desert include like the Atacama, Sahara, Arabia, Thar, Namib, Kalahari, etc. We've already done this in the, all these labelings have been already done in the mapping series which we have completed it. And one short video has already been uploaded. Temperate desert, Patagonia, Central Asian deserts and Mojave desert. So these are the temperate. So they have received less than 25 centimeter of rainfall. Now, though this is part of India, but I'm just covering it because we are doing the concept of rainfall. Let us do it from the perspective of India also. If you see, this is a handmade diagram again, a map. The regions which you see are in red. These are either areas of high rainfall. This can be asked in your paper, so be very careful about it. 200 centimeters, greater than 200 centimeters is over here, this part and this part, right? Now, if you go to the regions from 100 to 200, you will realize that the regions adjoining the high rainfall regions, these coastal regions and this belt which is present here, this is basically medium rainfall from 100 to 200. If you see from let us say from 50 to 100, this region, interior part, even this are from 50 to 100. If you see the least, the conditions where rainfall is less than 100, you see the regions of Rajasthan, over here Karnataka region, some parts of Madhya Pradesh also, and the Ladakh region. Let us see this now. Average annual rainfall in India is 125 centimeter. Areas of high rainfall, rainfall greater than 200 centimeters. Western coast of the Western Ghats, you've seen sub-Himalayan areas in the northeastern region and hills of Meghalaya. Khasi and Jaintia, rainfall greater than even 1000 centimeter, right? Areas of medium rainfall, which is from 100 to 200 centimeters, right? Southern parts of Gujarat, eastern Tamil Nadu, Bihar, eastern Madhya Pradesh, northern Ganga Plain, Kachar Valley, Manipur, Odisha. Odisha parts, not all, only the parts of Odisha, so make it very clear about it. When we move ahead, we realize that areas of low rainfall, that means rainfall between 50 to 100 centimeters, Western UP, Delhi, Haryana, Punjab, Jammu Kashmir regions, eastern Rajasthan, Gujarat and Deccan Plateau. When I come to the areas of inadequate rainfall, that is less than 50 centimeter, which we have already seen in this yellow part. This is basically parts of peninsular, especially Andhra Pradesh, Karnataka, Maharashtra and Ladakh. And Ladakh parts, right? And the Ladakh region. Okay. Variability of rainfall. Variability means between that how much variation is there annually when the rainfall bed is received throughout the year. So if you see the desert regions, they have a very high variability, greater than 60%. If you go beyond towards the eastern side, this is a region which have 30 to 60%. If you see the other parts, these are what? 15 to 30, and the regions which receive very heavy rainfall throughout the year, they have the least variability, like this region 15% or 15%. This is something that you should know. Why? Because the questions can be asked on them also. So this was the chapter where we studied water in the atmosphere. I've taught you from the perspective of the world aspect also and added the Indian component also for you to revise it quickly. So we will be coming with the next chapter, classification of the climate, and then oceanography and biodiversity, and we'll be done with this. So please stay tuned, do it properly, and please make sure that you revise it again. Take care and Jai Hind.